Welcome to Module 11, the most technical module in this course. We're going to go deep on OpenRTB, the protocol that literally powers programmatic advertising. This is where the business concepts meet the engineering reality. If you work in AdTech on the technical side as an engineer, a solutions architect, and implementation specialist, this module is essential. If you work on the business side, understanding OpenRTB will make you a better partner. OpenRTB, Open Real-Time Bidding, is a standardized communication protocol that governs how ad impressions are bought and sold through real-time auctions. Think of it as the common language that every DSP, SSP, and ad exchange speaks. OpenRTB is the plumbing of programmatic advertising. In the late 2000s, RTB was emerging as a concept, but there was no standardized way for platforms to communicate. Every ad exchange had its own proprietary API. If you were a DSP and you wanted to connect to 5 different exchanges, you needed 5 different custom integrations. OpenRTB solved this by creating one universal standard. Any DSP that implements the OpenRTB specification can connect to any SSP or exchange that also implements the specification. One integration, global access. That's interoperability. The efficiency gains are real. Standardized data formats mean requests can be parsed and processed at the speed required for real-time auctions. OpenRTB also promotes transparency. OpenRTB started as a grassroots industry initiative, which is unusual for a technical standard. The fact that competitors came together to create it shows how necessary it was. In 2012, the Interactive Advertising Bureau (IAB) officially adopted OpenRTB as the industry standard. This was a crucial legitimization. The IAB's endorsement meant the standard would be maintained, evolved, and evangelized across the entire industry, not just by the founding companies. Since then, OpenRTB has gone through several major versions. Version 2.5 added structured support for video and improved mobile ad delivery. Version 2.6 added connected TV support, enabling programmatic buying of streaming TV inventory. OpenRTB 3.0 is a major architectural update focused on enhanced privacy, improved user identification alternatives for a cookieless world, and support for new ad formats. Every major DSP, SSP, and exchange implements it. Today, it's maintained by IAB Tech Lab. When a user visits a web page, the publisher's SSP sends a bid request to ad exchanges. That bid request is a structured JSON message, a packet of information describing the ad opportunity. The bid request is the core message in RTB. Everything the DSP needs to make a bidding decision is in here: the ad format, the page context, the device, and user data. DSPs must evaluate this and respond with a bid or no bid within Tmax milliseconds. The ID field is a unique identifier for this specific bid request, a UUID generated for each auction. This is how DSPs and exchanges track which bid response corresponds to which bid request. The imp array impression array is the heart of the bid request. Each element in the array represents one ad placement being auctioned. For a page with 2 ad slots, the imp array has 2 elements. Each impression object contains details about the ad format, banner dimensions, video length and format requirements, native ad component specifications, and the bid floor, which is the minimum CPM the publisher will accept. Bids below the bid floor are automatically rejected. The site object describes the web page context, the domain, the specific page URL, and the IAB content category of the page. A DSP can use this to determine whether the context is appropriate for their advertiser. An alcohol brand can check whether the page is on an adult-only site. The app object is used instead of site for mobile app inventory. It contains the app name, bundle ID, and store URL, information the DSP can use to evaluate the app context. The device object contains information about the user's device, the user agent string identifying their browser, their IP address, their inferred geographic location, the device type, mobile, tablet, desktop, and the operating system. The user object carries user-level data, any available identifier, demographic signals like year of birth and gender if consented, and interest keywords. The regs object is important for privacy compliance. It carries flags indicating whether the request is subject to COPPA, a children's privacy flag, and whether GDPR applies. DSPs must respect these flags when deciding how to use user data in their bidding. The Tmax field specifies the maximum time the exchange will wait for bids, typically 100 to 150 milliseconds. Any bids received after Tmax are rejected. When a DSP receives a bid request and wants to bid on it, it constructs a JSON response and sends it back to the exchange before Tmax expires. If it doesn't want to bid on any impression in the request, it returns HTTP 204 no content, which is the standard way to signal a no bid without consuming unnecessary bandwidth. The bid response matches the bid request's ID at the top level. This is how the exchange connects the response to the specific auction it belongs to. The seat bid array contains one or more seat bid objects. A seat is an advertiser or buyer seat within the DSP. A DSP might represent many advertisers, each with their own seat. Each seat bid can contain multiple bid objects, each bidding on a different impression from the bid request. The bid object is where the substantive information lives. The impid matches the impression ID from the bid request. This bid applies to that specific ad slot. The price is the CPM bid in US dollars, how much the DSP is willing to pay per 1,000 impressions. The ADM field contains the actual ad creative markup, the HTML or JavaScript code that, when rendered, displays the ad to the user. For video, this would be a vast tag URL rather than inline HTML. Then there are 3 notification URL fields, nurl, burl, and lurl, which we'll cover in detail in the next lesson, as they're complex and important enough to deserve their own section. The domain field lists the advertiser's domain, used for brand safety checking and frequency capping. An exchange can block a bid if the domain is on the publisher's block list. Looking at the code example on the slide, you can trace exactly how these fields map to real values. The bid ID, the impression it's bidding on, the price of 75 cents CPM, the ad markup, and the 3 notification URLs with their macro substitution placeholders. These 3 URLs are how DSPs receive feedback from the auction. nurl tells you when you won. Burl tells you when you're being charged. lurl tells you when you lost and sometimes why. Loss notifications are particularly valuable for bid strategy optimization. PMPs represent the convergence of direct sales and programmatic. Publishers get the control and pricing of a direct deal. Advertisers get the targeting and automation of programmatic. Deal IDs are the key technical mechanism. A PMP is an invite-only programmatic deal. Publishers offer specific inventory, often their premium placements, to a curated set of advertisers before or instead of making it available on the open exchange. The transaction still happens programmatically through RTB mechanisms, but within a controlled, trusted environment. Why do PMPs matter? Publishers value them because they enable premium pricing, brand safety control, and direct relationships with preferred advertisers. Advertisers value them because they get access to premium inventory that may not be available in the open exchange, better transparency into where their ads are running, and protection from the fraud and brand safety risks that are more prevalent in open exchange environments. That wraps up Module 11. Let's quickly recap what we covered. What is OpenRTB and why do we need it? OpenRTB history and IAB adoption, the bid request, structure, and key objects, the bid response nurl, burl, lurl, notification URLs, private marketplace, PMP.